All right, so we're still looking at ways to figure out things for probability, and we're going to look at now using tree diagrams. Now, what makes these different to tables is that these will work for when you've got more than more than two things happening. Okay, so let's have a look how this works. Okay, so these, you can apply these to a situation where you can use a table, but they're specifically useful for when there's more than two things going on. So in other words, you can't use a table for them. You've got to go with a tree diagram. Okay, and remember, this is just a way of establishing the sample space. We're looking at trying to find out what is actually possible. Okay, what is the full list of things that are possible? And once you've done that, that is the hard work. To figure out the probability then, it's just a matter of counting. Okay, once you get the sample space, that's the hard work done. Okay, so let's have a look at what we can do. So first of all, let's say I was going to do a coin toss, but I'm going to toss it 3 times. Okay, so I'm going to go, number 1, what's that? That's head. Second one, that's another head. And let's do a proper one there. And that's a tail. All right, so here's a question. I just got 2 heads and a tail. I wonder what the chances are of getting 2 heads at the start. Okay, I have no idea, because I don't know what the full list of possible things is. I can actually figure this out, but I need a tree diagram to do so. So let's look at how a tree diagram will work in this case. Okay, so I'm going to start off with the first time I toss the coin. Okay, so when I toss the coin for the first time, I've only got 2 options, haven't I? I can go head or tail. Okay, so that's the first time I toss the coin. Bang, head or tail. Okay, first one. Okay, so once I've done the first one, I do it again. But if I get a head here, I can still get the same thing. Like, just because I've got the head there doesn't change what's possible a second time around. Okay, so there's the head, and I got another head, but I could have got a tail. All right, so doing that, getting that the first time around doesn't change what's possible a second time around. So when I do it the second time, I've still got those as options. Okay, so what's happening here is that's the first throw. There's your first throw. This is the second throw. Okay, now I'm going to go for a third throw. Each time, so these are different branches of the tree you can possibly follow. Okay. All right, and so first throw, second throw, third throw. All right, so what is the sample space? That we haven't got the sample space yet. This is just a tool to get the sample space. So what we need to do is to just follow the line and figure out what's going on. So look at this first one here, head, head, head. So that's the first possibility, 3 heads in a row. Head, head, tail. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. All right. Now, this list right here, that is the sample space. This diagram, that's just the way of getting the sample space. If in the test you just produce that, you will get marked down because you need the sample space. That there, a list, is the sample space. Okay? So, before, when I started, I had no idea how many things were possible. But look at this. We know that there are 8 possible outcomes. Okay? Didn't know that before we did the table, before we did the diagram. There are 8 possible combos we can have. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, how do the questions look? So we might go, righto, what's the probability of getting 3 of a kind? 3 the same, whether it's head, 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 or tail, tail, tail. Okay, well that happens twice. There and there. Now, until we did this, I had no idea what was going on. But now we've got this, all we've got to do is count. There are 8 possible combos. And this thing shows up twice. Okay, so that is a quarter. Okay, so a quarter of the time I can get 3 of the same. All right. What if I want, let's see, tail, tail, tail at start. I want the first 2 to be tails. How many times does that happen? Well, that happens twice again. Okay. But I wouldn't have known that unless I had this happening. Okay. And you can go on. You can say, well, what's the chances of getting just 2 heads? Okay, not 3 heads, not 1 head, but just 2. Well, we got 1 in any order. 1, 2, 3, 3. 3 out of 8. Okay, so all you got to do is count. Getting that, that's the hard work. All right, so that's one kind of tree diagram. Let's look at another one now. Let's say I've got 3 cards. Okay, so don't worry about the fact that they're hearts, but I'm just looking at the numbers. I've got 2, 3, and 4. What if I'm going to make numbers by randomly drawing these? Okay, so check it out. I'm just going to shuffle them up a little. All right, so here we go. 243. Let's do it again. 423. 243. Okay, so this is just a random way of making these numbers by drawing these cards. But here's the thing. Let's look at what's happening here. If I drew this first one, okay, I've got a 3. I had these options, didn't I? This was all that was my first draw. They are the 3 things that are on options. Let's say I picked that one first. Well, now that I've picked that one, I no longer have 3 things to pick from. I've only got 2. In other words, what's available at each step of the tree diagram, it's changing, okay? It's getting less because I've drawn it out, it's gone. And then let's say I picked that one, okay, well then obviously I've only got this one left. Okay, so how do we do that on a tree diagram? Well, it's actually pretty simple. All right, so my starting thing, I can get a 2, I can get a 3, I can get a 4. Now, it really doesn't matter what order I put them in, okay? If I get, you've got to play the what if game. If I get a 2, it's gone. So when I do it the second time, I've only got a 3 and a 4 left in the hand, haven't I? So I can get a 3 or I can get a 4. If I pick the 3 first time, well, I've only got a 2 and a 4 left in the hand. So that's what's there as a possible for the second draw. First draw, second draw. If I got a 4 the first time, well, the only thing that's left, see, this is what's happening here. I've got this, right? I pull the 4 down. Well, the only thing that's left is the 2 or the 3. Okay? So now we go up here. So I've got a 2 and 3. So let's say, here's my hand, okay? I pull down the 2 first, pull down the 3 second. Well, the only thing that's left is the 4. So it's a 4. If I had the 2 and the 4, that's the first lot. All that's left is the 3. Okay, and you can just keep on like that. Okay. So first draw, second draw, third draw. All right, but that's not the sample space. Remember, a sample space is a list. So we now follow the lines. So that's 234. 243. Let's just keep on going here. Okay, so before I did this, I didn't know that there were 6 options. Okay, had no idea. You've got to actually do the hard work to get this, and now it's just a matter of counting. So let's say I wanted the probability of a number greater than 340. Okay, what's the chances of getting something that's more than 340? Before you do this, I have no idea. Now you just got to count. Okay, so there is 6 options in total. That's less than 340. That's less than 340. That's more than. So I want 1, 2, 3. Half of the time, I'm going to get something more than 340. Okay. What's the probability of getting something, in the 400s? Okay. Well, there's only 2 of them. But again, it's over 6. 2 over 6. Again, if you're really not certain about this, the fraction thing, go to the fraction button on the calculator. Get it to simplify it for you. You've got to simplify the fraction. Never, ever, ever write a fraction without simplifying it. Okay? You will lose marks. All right, so that's how tree diagrams work. It's just a way of establishing the sample space when you've got more than 2 things happening. Okay?